The Vertica Analytics platform is purpose-built from the very first line of code for big data analytics. It is designed for use in data warehouses and other big data workloads where speed, scalability, simplicity, and openness are crucial to the success of analytics. Vertica relies on a tested, reliable, distributed architecture and columnar compression to deliver this blazingly fast speed. In this video, we're going to concentrate on how Vertica achieves such fast query performance by restructuring row-based tables into column-based projections. To process even a simple query such as the one shown, a row-stored database must read all columns in all of the tables named in the query, regardless of how wide the tables might be or how many columns are actually needed. This limits the speed at which you can get an answer to your query. This is even more of a concern as your queries get more complex, referencing multiple tables to return a result. In contrast, the Vertica database transforms the information from a table into a column-based structure we call projections. For this query, we're only referencing 3 of the columns from the table: symbol, date, and price. So these are the only columns that need to be contained in the projection. You will get a faster query response by not having to reference all the information contained in the table. There are 2 basic types of projections that can be built based on a table. If you have frequently run queries, you can build projections that are specific to those queries. Vertica will automatically choose the projection that best fits the query, and query performance is also increased because the data in each projection is automatically sorted. But what if you need to run an ad hoc query? For each table, Vertica also creates at least one super projection. Super projections contain every column in the table, and each of them can sort the information differently based on the types of ad hoc queries you expect. Vertica is installed on a cluster of machines called nodes. The physical database is distributed across these nodes, and all of them participate in the processing of information. Projections can also be distributed across these nodes. If you have a large fact table, that is, a table that contains a large number of rows, Vertica will segment that data into related projections and distribute those segments across all the nodes in a database. This way, the processing load of a query request is distributed, and the performance of the query increases. However, if you have small dimension tables, it may not pay to segment that data across the nodes. In that case, Vertica will simply make a copy of that data, that is, replicate it on each of the nodes. Queries made across multiple tables are where the power of projection segmentation and replication is best demonstrated. In this case, we want to join information between 2 tables. Each node, working independently, runs the query on the data located on that node. Because the node contains only a segment of the data from table A, the query is processed much more quickly. The results from each node are then aggregated, and the result returned to the requester. Thanks for watching. There's a lot more to learn about Vertica's projections. In the Vertica Essentials instructor-led course, you'll learn more about how projections are structured and how to use the Database Designer tool to automatically build the projections you need to return analytic results as quickly as possible. In the Vertica Query Performance Tuning class, you'll learn how to analyze your production queries to identify performance bottlenecks and how to manually customize projection design to meet your changing production requirements. Look in the notes below for a link to the course registration system. And finally, you can access the full Vertica documentation set from the My Vertica portal. A direct link to the section on data storage and projections is also in the notes below.